Let's begin running or hand-on with the software. If you are running, your computer have Windows 7, 8 or Windows 10, we suggest that you right hand click on the executable file or the shortcut. You go to properties and then you go to tab compatibility. Okay, you run it in compatibility mode for Windows XP Service Pack 3. You also run as an administrator. Apply here and then click OK. Okay, proceed here. Just disable the timer here. Okay, go to module 1 to match three-phase KR or PC data. Alright, let's select one set of data. Let's say we select the Snell data, 1962 data. Alright, it has KRO, KRIG, KRW data, no PC data. Mesh it, then generate the ternary diagram. These are the data point. Okay. Right. KRG, KRW. Alright. Let's look at the matching accuracy. See here the R squared coefficient 0.86, 0.95, 0.98. Alright. Okay. We plot here calculated KR versus measured KR. If the point lies on the 45-degree line, they are perfect matches. Otherwise, it's less than that. All right. Let's generate a two-dimensional table. You can also generate for empirical models, stone one modified by Aziz and Satari and others. Right? Okay. Let's generate two-phase data. Okay. Alright. It's generating the table, numerical table as well as the curve. Okay. Let's use this two-phase data to regenerate, to reversibly generate two-phase. Alright. Okay. You can compare with the this with the originally matched data. They are essentially identical. This for KRG. Let's see also. They are matching, almost perfectly matching. Alright, just to show you the two-phase data that we have used, we click this include data point in the ternary plots. Right. Example for the KRG. This is the two-phase KRG data that we use to regenerate the three-phase KRG. Alright. Then we go to rescaling, set the initial scaling. What does it mean, rescaling? Suppose that in doing simulation work, users wish to apply one set of mesh KR and PC data to different grid blocks with different residual and endpoint parameters. This software can rescale or denormalize the KR and PC data to different residual saturation as well as different endpoint or maximum point. Okay. Let's try changing this to 1. See? Also the maximum, you can put all 5. Then you can generate the table as well as generating the rescale ternary diagram. They look the same, but the endpoint are different. Alright. Okay. We don't have this data doesn't have PC data, so it's 0 then. Okay. Let's go to model 2. Okay. Model 2 gives you initial KR and PC curve along two-phase path as well as along SORM line. You can change. Here. If you want to change the parameters along SORM line, you click here, and you can change it. Alright. Again, this as extra display. You can, if you have multiple screen, you can watch, you can see. Okay. So these pictures B and C represent ternary illustration of the saturation spaces of the two-phase relative perm and cap pressure and endpoint saturation, initially shown in picture A. This picture B shows similar plot to those in figure 1 in SPE 74705 paper. Okay. This you can have a upright like here, or you can plot it upside down. All right. Okay, you can change the PKR parameter, PC parameter, and you begin to generate. You can review the input data point. This KR WPC data point along the two-phase path as well as along the SORM line. Okay. Then you can generate two-phase data for your two-phase simulation. Then let's generate. Okay. Model 2 run completed. Alright. Okay. Generate three-phase data. Alright. Use this command for the reduction parameters for PC more than 0.3. Let's see. Change one. Where are the reduction parameters? Yeah. Let's put 0.4. Or even 1. Let's try. Okay. Display general diagram. KRO, KRW, PCGO, okay, PCOW, alright. Let's see the matching accuracy. KRO, KRG, KRW, PC, GOPC. Oh, you can see the accuracy matching the two-phase data. Alright. Then if you have lab data, you can also input here. Okay. Here, generate three-phase KRP data for module 1. What does it mean? It means that this command will generate you this number. This number. Okay. Let's try. Reduce. Have to be more than 0.3. 1.5. or here. Let's put one, both. Okay. Okay. These commands generate KRPC value at random saturation point. Matching of PC data by module 1 will be less accurate due to substantial PC coverages. Moreover, module 1 does not have secondary optimization that module 2 has. However, users can use module 1 rescaling option by specifying minimum and maximum PC values to obtain similar PC curve as originally generated by module 2. Okay. Alright. September 28th. Alright. Let's see, we use this data to rerun module 1. Here. Okay, now we have all 5 parameters: KRO, KRG, KRW, PCGO, PCWO that we generate using module 2. Let's do some matching. Generate. Okay, these are the random data point that we generate using module 2. Okay, see, this is the first that we got by running module 2. This is the curve that we got by regenerating the data point and rerunning it, rematching it with module 1. Okay. Similarly for water, you can see here, almost identical. Okay, for gas, no, for PCGO, okay, slightly different but still very good mesh. Alright. Okay, then what do we have left? This is PCOW. Okay, compared to the first mesh, and this is using module 1. They are very much the same. Now we have left KRG, I guess. Look at here, they are also comparable. Alright. Okay. Let's go to module 3. Okay, module 3, will use two-phase KRPC data to generate two-phase or three-phase data for specific denormalized parameters. Right? Okay. If you have lab data, you can input here. Okay. Let's open a file that contains the lab data. Middle one. Okay. You can put drainage, ambition, or both. You can plot test data or normalize the data. Okay. And then you can create multiple sets, and you give it a different residual saturation and endpoint, meaning that if you have 3 sets here, you'll be able to prepare 3 set data for your reservoir simulation. Okay. Output, generate two-phase data table, right, which you can copy and paste. Okay. And then generate three-phase table also for set number 1, set number 2, set number 3. Okay. Also two-phase KRPC data, KR data only. Alright. You can to number 3. Okay. Okay, these are your lab data. Okay. Generate KRO ternary diagram. Okay, because you will last click 3, it will appear 3. If you click 1, it will appear 1. Okay. So this is data set 3. Alright. Oh, this is drainage, this is ambition curve for set number 3. Alright. That pretty much end our presentation. We thank you for watching, and we hope that you will try our software. Thank you.